Last one, example 4, x squared plus 5 plus 6x. So, notice once again, the linear term is out of place, the constant is out of place, so I need to rearrange this to begin with. So x squared plus 6x plus 5. Always start off, when you copy the problem out of your book onto your paper, I recommend writing them on your paper every time. Copy it out of your book onto your paper in descending order. Just right off the bat, just rearrange it. Make sure the signs don't change. There's no equal sign here. So 6x moves left, positive. 5 moves right, stays positive. There's not moving across an equal sign to change a sign. So some people think that's necessary.
What is the FR stand for?
Oh, factors of. So we want factors of positive 5, and we want the sum of those numbers to be positive 6. Okay, so multiplying things up to make 5. Positive 5, same sign. Positive 6, both positive. So 1 and 5 make 5, right? And 1 plus 5 makes 6. So that gets me the magic numbers right off the bat. Parentheses, parentheses. The letter this time we're using is x. We put a plus 1 and a plus 5. We get our answer. I want to show you two things that didn't happen yet, but they'll happen probably in your homework before I visit this topic again. Okay, first topic is this. Suppose we're factoring numbers. Going back to just like if I did 12, again that's 2 times 6, and then that's 2 times 2 times 3, right? Suppose I wanted to factor 17. What can we do about 17?
17 once.
It's just 17. It's a prime number, right? Okay, every one of these has been factorable so far. What if we get one that doesn't factor? What if we get one that can't be factored? What if there's some sort of a prime quadratic expression? Let me show you what that looks like. Let's make 12. There we go. X squared plus 3x minus 12. Let's go with that one. All right. Doesn't look any different than the other ones, right? X squared, something, x something. And if I did my chart here, factors of would be negative 12. We want the sum of those factors to be positive 3. All right. If I start off, I'm opposite signs to make a negative, and a bigger number positive to make a positive. So negative 1 and positive 12 makes 11, not 3. Negative 2 and 6 makes 4, not 3. Negative 3 and 4 makes 1, not 3. The next number up is 4. If I go negative 4 and 3, that makes a negative 1. Now I'm starting to get negative sums, so that's no good. So every pair of numbers that multiplies to make negative 12 doesn't also add to make 3. That represents prime. So if you do your chart and you got every single pair over here, and not a one of those pairs makes the correct sum, you write prime. It does not factor. It's not possible to factor. Okay? Other situation. Every one of these numbers has been pretty reasonable, right? Suppose they give you x squared plus 29x plus 120. Suppose they give you something like that.
Yeah.
All right. This is one where if you do a systematic list, in other words, try 1, then try 2, then try 3, then try 4, and so on. If you do a systematic list, you don't leave any out. Because a lot of times people get one like this, think of everything they can think of that goes into 120, they leave something out, and all of a sudden you don't have a complete list. You don't see 29 on there, you think it's prime, but it isn't. All right, so if I make a systematic list here, again, what I mean is we want factors of positive 120, we want the sum of those factors to be positive 29. Both positive, right, to make this happen? Start at 1, 1 times 120. Wrong. Next number up, 2. 2 times
60.
60, which makes 62. Wrong. 3 times
40.
40. And that makes 43. Still wrong. 4 times 30 makes 34. Still wrong. 5 times
24.
24 makes 29. Got it. All right. But again, if you just start listing stuff without going in a pattern like this, going one at a time up, the next number up is 6 times 20 makes 26. 7 doesn't go into 120. 8 times 15, 23. These are pretty forgettable factors of 120 that people just don't think about, but they are. So if you just go one at a time through it, does 1 go into it, does 2 go into it, does 3 go into it, and so on. Next number up, 9 doesn't go into 120. 10 times 12, so 22. 11 doesn't go into it. 12's already been reused, right? So now I've got the whole list. Just like that, going one at a time through the numbers. all I do is go up to 10 and I found every single factor of 120. Every one of these numbers represents a middle number that could work to factor. If any one of these middle numbers was there, you have the correct factored form. Correct one we have here is 5 and 24. So x plus 5, x plus 24 would be the factored form of that one. But again, do your list in a systematic way. You do not leave any factors off. That's the most common mistake people make. They just forget about a set of factors. They say it's prime because they didn't find the right pair, but it actually isn't prime. So take your time through that and make sure this list is complete in order to get this. And again, if you add them up, once I found that, I didn't have to find these other three. I just wanted to show you how many more there were in case you did have to find more.